Hello. The main purpose of this tutorial is to develop this truss in the Ansys. So first of all, we need to open Ansys. I have it right here. We're going to go through a series of steps in order to get the truss finished and in order to obtain both the stresses in the bars, the deflection of the structure, and finally how it would look because of that deflection. First of all, we can look at this structure and we can notice it has 7 nodes. Here we have its coordinates. It's important to notice that as we have them in millimeters, Ansys does not recognize this type of units, so we need to be sure which type of units we are working with. In case we use millimeters, the elastic modulus should be in megapascals. So we're going to start with the modeling. Here we have Ansys, and we're going to get in the first step preprocessor. First we need to define which type of element we're going to use. In this case we click on element type, then add, edit, delete. We're going to add one type of element, which is a link, and we select the first option, which is 3D finite 180. We click in OK. Then we click close. That's all we need to do to define the element type. What we have just done is to define it's going to be links with bars that keep no stresses because of moments, just axial stresses. The next step is to define the real constants of the element we're going to use. In this case, as they are trusses, we need to define the area. So we take a look at the document we have, and they tell us that for the horizontal bars is 4,000 millimeters squared, and for the diagonal bars is 3,000. So we need to define both areas. The first area we're going to define for the link. We need to click OK, and then it says the real constant set number 1. It's going to have an area of 4,000 square millimeters. Then we click OK, and then we need to add another set to tell it's another area, and it's going to be 3,000. We click OK. Now we can close this. In material properties, we're going to obtain the type of element we're going to analyze. In this case, we click material models and then structural, linear, elastic, and isotropic. For the modulus, as we have already stated, it needs to be in the order of the megapascals. So it's going to be, we look at the image, and it's going to be 200,000. In this case, the Poisson is not required, but we should only state it's 0.3 because it's steel. Then we click OK. Now, as we have defined everything that's related to the type of element we're going to analyze, it is important to know that every type of analysis is going to require different steps in order to define what we're going to analyze. In this case, we're finished. So it's time to start modeling the structure. For that, we go to the modeling and we click on it. Then we click on create, and the first thing we're going to do is create the key points. So we look again at the structure. Here we have the coordinates. It is important to know that Ansys does not need the nodes that have restrictions to be the first one or the last ones. It doesn't matter. So we can define any node anywhere, and then we can apply the conditions it has. So we're going to follow this table. So first of all, node 1, we're going to create key points in ActiveCS. So we don't need to define what key point number is. Ansys does it by itself. So the first one is 0, 0, and we click apply. Then 1800 and 3118. We click apply. Then 3600 0, 0, then 5400, 3118, 7200 0, apply, then 9000, 3118, and finally 10800 0. So it seems that we have one key point missing, so the 3600 and 0 coordinates not there. It doesn't matter, we can go again to ActiveCS and define it. So 3600 and 0, we click. Now we're going to click OK, because if we click apply and then click OK, the Ansys program is just going to define both key points with the same coordinate, and as we're going to have two lines may not be connected, so in order to do not have that problem, we just click OK. There we are. We have the key points needed. Okay, so now we need to connect those key points, because the connections are going to be the bars defining the structure. So we go to lines again, straight line, and we're going to pick each pair of nodes that define the line. So 1 to 2, 2 to 3, 3 to 5, 5 to 6. Here it doesn't really matter which element we're trying to unite, as Ansys is going to give each bar one number. So if we have another set of bars, another order in which I have defined them, it doesn't matter. I can check in Ansys which bar is which element and then compare it to my results handmade. So now that we have finished with the lines, we need to go to the meshing menu, and then we're going to define, this is very important, that as we have not one area but two different areas, we need to define that some lines have one area and some other lines have the other one. So we need to go to the mesh attributes, and then we're going to look back. It says the horizontal bars are the ones that have the first area that we defined. So we're going to pick the lines, and we're going to say that these ones, okay, this one have the set one of the material, the set one of real constant number, and then we just click OK. Then we need to define that the other lines have the second set, so we pick those lines, we click OK, and then we're going to say that it has the second real constant set number, we click OK. Now each type of line is related to its area. In order to continue, we need to mesh the structure, because we have not done that. We only define what are the characteristics of each bar. Now we need to mesh in order to for Ansys to analyze completely what's going on. So we go to Mesh tool, and we're going first to Set in Lines, and we're going to click on Pick All. This in order to define that we only need one element per bar. If we say 2, Ansys is going to add another node inside the line, which is able to rotate. We don't want it. So one division, we click OK, and there we are. We have the graphic changes, but the lines are the same. It is not meshed, so we go again to Mesh tool, Mesh, and we click Pick All, and that's it. As it turns blue, now the structure is meshed. If we want to see which elements we're working with, we go to Plot Controls, Numbering. We can close this one, and we can click here, Element Numbers, and we click OK, and there we are. The element numbers we're going to obtain the result of. So if, for example, you said this bar was element 8, you need to compare the results from element 2 to your 8. Okay, that's it in the meshing menu. Now we need to apply the loads. We go to Loads, Define Loads, then Apply, Structural, and Displacement. We'll take a look at the drawing, and there says that nodes 1 and 7, the ones in the edges, are going to be restricted in every sense. So we go back to the Ansys program, and we click on the displacement. This is very important. If you define that the key points are the ones that cannot move, in this case, both nodes and key points share the same location and share the same characteristics. But in other type of elements, they do not. So we better choose nodes, and we're going to pick this one and this one, and we click OK. Then we're going to tell the program that every degree of freedom is going to be restricted, 0, and we click OK. That's it. Now we need to apply the forces. So we take a look back at the drawing, and it says that 300,000 newtons, both nodes 3 and 5. So we go back and we click on Structural Force Moment on nodes. We're going to pick these ones below, and we click OK. Now it's a force in the Y direction. It's a constant value, and as it's going downwards, it's going to be minus 300,000. In this case, the millimeters and the megapascals do not interfere with the forces, so forces should be entered the same as they are stated in the drawing. So minus 300,000, and we click OK, and that's it. There we have our forces. This time is a very good time to save the program. Now we can close this, and that's it. We have finished with our preprocessor work. We go to the solution now, and we click on Solve, Current LS, OK, and that's it. Ansys has the solution now. In order to read the solution, we need to go to the next menu, which is General Post-Processor, and first of all, we can plot the results, which is the deformed shape. We click the last option, and we click OK. That's it. That's the structure as it will look. It's important to notice that Ansys often exaggerates the results, so it's not going to look that way in the real life. It has a multiplying factor. As we know that how it's going to deflect, it is not the only data we can obtain from here. Now we can go to nodal calculations. No, that's not. We can go to plot results, control plot, null solution, degree of freedom, and there we have both the x component of displacement, y component, and the z component. In this case, we should care about the y component. So we click on y, and we click OK. And there it is. Ansys stated that the biggest deflection is minus almost 7 millimeters downwards, which is something. And well, it agrees with what we would expect from the structure. Now, because it is a truss, Ansys does not give us the stresses in each bar by default, so we need to ask it. In order to do that, we go to element table, and we need to define a table. So we click on it, we click add. Here I get these options. I need to give a name to a table. I'm going to name it SX. And I scroll down to the option that says by sequence number, then click LS, and I should say it is the one. I click OK, and I click close. Now I go to the next option, which is plot element table. It is by default the one I just defined, SX. I click do not average, and OK. And that's it. The stresses in each bar. Now, this would be the end of the tutorial. Thank you.